Hello, everyone. Welcome to the workshop. And my name is Bowen Dung. And my presentation is to give some examples of extreme events analyzing previous CSSP China workshop. And as some said, and the workshop is organized by some talent from University of Reading and helped me by myself and Fraser Lott from my office, Sal Sparrow from University of Oxford, and Ying Sun from Chinese Meteorology Administration China, and plus many others, include both UK tutors and China tutors, and of course include many participants. And my presentation outline is first, I will give an overview of the previous workshop, and then I will talk about some temperature extreme analyzed in previous workshop, and then the precipitation extreme analyzed in previous workshop. Wow. So this is an overview of previous workshop, and so far, and we have organized 4 workshops altogether. And the first one is Edinburgh workshop in December 2016. And in this workshop, and participants have analyzed 2 events, and that's January 2016 East China cold surge and May 2016 South China heavy precipitation. And the second workshop was held in Oxford University in 2018. And this workshop was joined with CSP Brazil workshop, and so only one event, that July 2017 Central China heat wave was analyzed. And then the third workshop was held in Beijing. And in this workshop, participants have analyzed 3 events. That's summer 2018 Northeast China heat wave, and summer 2018 Southwest China heavy precipitation, and summer 2018 North Hemisphere heat wave. And the fourth one was in last year in Zhuhai campus of Sun Yat-sen University. And so in this workshop, participants have analyzed 4 events. One heavy precipitation event in South China from March to July, and also short duration heavy precipitation in July. And another event is extreme low precipitation in Southwest China from May to June, and a long-lasting precipitation over South China in the December 2018 to February 2019. And so far, and during 4 workshops, and 10 events have been analyzed, and participants have published 9 papers, and with 7 in BAM's special issue, and 1 in revision for Chinese Science Bulletin. And so this is the first 3 workshops, and that's the Edinburgh workshop, and that's Oxford workshop, and that's Beijing workshop. And this fourth workshop, and I said, and this workshop analyzed 3 events, and so with 4 papers and 3 published in BAM's special issue and 1 published in Frontiers Environment Science. And unfortunately, in this year, and we have been all on virtual, and so we cannot, for example, take group photograph, like, for example, in previous workshop. And because this workshop is about event attribution, and so here, and I think some already show this slide, and so it's better to illustrate once again. And so what is the event attribution? And very often after weather or climate event has occurred, and there's a great medium and public interest in asking how much anthropogenic forcing or who, for example, human influence has contributed to the change of probability that risk or magnitude or severity of that event. And while a specific weather and climate event cannot be solely attributed to a single cause, and it's still possible to estimate, for example, horizontal factors like like the change of greenhouse gas forcing may have modified the probability or contributed to the magnitude of that kind of event. And so attribution is a process of evaluating the relative contribution of different forcing factors to a change or an event with assignment of some statistical confidence. And some already showed this, 6 crucial steps for event attribution. And I think Sarah will also cover this, but I think it's worth to repeat this once again. And so these 6 crucial steps for event attribution. And first, you need to decide, for example, what has happened, what the impact of this event, and then you have to decide what event and what variable you want to investigate, and what special patterns or special extent of that event, and what time scales. And the third step is to evaluate the models. And where the model has, for example, correct physical process to capture, for example, historical evolution of that kind of events. And then you calculate, for example, this kind of event, the retain period in a simulation with, for example, which includes anthropogenic forcing against, for example, natural world or counterfactual world, which removes, for example, human influence. And then you give, for example, some uncertainty estimation about, for example, probability you estimated from both real world and counterfactual world, and then is the communication your result to the other public, or, for example, publish your result in scientific literatures. And so this is illustration. Is a schematic illustrations how to, for example, calculate the probability. And so this is a climate variables. And so it's for example, some event you considered. And so blue line is the counterfactual world, and red line is the factual world. And so for event, and you need, for example, to find a threshold, and that dashed line is a threshold of some variable or event. And so for two, for example, Y is counterfactual world and Y factual world, and this is a probability distribution, and for event, for example, exceeded that threshold, and the probability is different. And for example, in natural world, probability is P0, and in real world or actual world is P1. And so in current literatures, and we use a risk ratio, and that's P1 divided by P0 to characterize the risk ratio. And in older literature, and it uses the concept of attribution risk, and that is defined by 1 minus P0 divided by P1. And this attribution risk quantifies the fracture event attributed to the human caused climate change. And in terms of model simulation used,